All right, so let's talk summation notation, folks. So just to review, this is what we did on summation notation. The notes aren't in there because I just annotated as I went. So when you see summation notation, it's the big E or the sideways M, which was what somebody called it the other day, and I'd never heard it referred to that. But anyhow, so when you look at the big E, what you see is basically there's some sort of index here. So this is basically whatever the variable is in your formula that goes here, that's what the variable is here. This is your index. Usually it starts with 1 and it ends at some number, maybe 8. Okay, so this is your start. This is your stop. And this right here is sigma from the Greek alphabet, which is for S, which stands for sum. And then there'll be some sort of formula in here. So it'll be some sort of sequence formula, or it would be any type of formula, to be honest. So it might be, we're going to do the sum from n equals 1 to 8 of 4n minus 2. So what that actually means is we're going to put in 1. So 4 times 1 is 4, minus 2 is 2. Then we say, okay, we got to stop at 8, so we're going to go around and we're going to do 2 this time. So we put in 2. 2 times 4 is 8, minus 2 is 6. We've got to stop at 8, so we're going to do 3 this time. 12 minus 2 is 10. Got to stop at 8, so we're going to put in 4. 16 minus 2 is 14. 5. 20 minus 2 is 18. I just realized I've been putting commas here, and they should be plus signs because we are doing a sum. So 2 plus 6 plus 4 plus 10 plus 14 plus 18, so that was 1, 2, 3, 4, 5. Our sixth term is 24 minus 2, which is 22. Our seventh term is 28 minus 2, which is 26. Our third term is 32 minus 2, which is 30. And then we add all of those up. So we'd have 2 plus 6 is 8, plus 8 is 18, 18 and 18 is 36, 36 and 14 is 50. So I got 50 there. Then I've got 48 and 30, which is 78. So that should be about 128. And you could always type it in your calculator. Now we also know that we can use Desmos to find this sum. So if we go to Desmos graphing calculator and we hit functions, we hit our keyboard and we hit functions, miscellaneous, sum, we're going to go from 1 to 8 of, and we had 4n minus 2. And there's our total, 128. And I said, when I calculated it by hand, 128. Now, so on the other page, we had done this practice where we were doing to find the sum of this sequence. Well, if I take a look at that sequence, I can do that. So I want to find my arithmetic sequence. So a sub n would be the first term is 5. I'm adding 4 each time. So when we simplify that, we have 4n plus 1. So to write this as a summation notation, we're finding the first 4 terms. So we went n equals 1 to 4 of 4n plus 1. And that would equal 44. Okay, now if we think back to the Gauss problem when it says to use limit notation to describe the sum of the first 100 counting numbers. Well, if I think of my counting numbers, that's 1, 2, 3, 4, ... So my first term is 1. My difference is 1. So my formula for the counting numbers is 1 plus 1 times n minus 1, which is 1 plus n minus 1, which is just n. So to find the sum of the first 100, I would do the sum, n equals 1 to 100 of n. Now, if you don't like n and you want to use a different variable, that's fine. Sometimes you'll see I used. but this index has to match the variable. These two have to match. Sometime you'll even see k used. Okay, but that's summation notation.